Hello, this is Miss McCauley, and this is Dividing Fractions by Fractions Part 2. When you complete this video, please answer the questions in the note check before moving on to your practice.
I'm going to start by writing down my original problem, which was 1/2 divided by 1/4. And again, I'm going to start by modeling my first fraction, which is 1/2. Then I'm going to see how many times that second fraction, 1/4, will fit into 1/2. So now I'm going to pull out a bunch of 1/4 pieces and pull them underneath my 1/2. And there we go. We can see that it fits in a total of 2 times. So my answer is 2. Go ahead and take a picture, drop it into GoodNotes. Okay, now we're going to try it using an equation. So I'm just going to start by rewriting my original problem, which was 1/2 divided by 1/4. Alright, so we're going to start by rewriting this as a multiplication problem. 1/2 stays the same. My division sign becomes a multiplication, and I'm going to find the reciprocal of my second fraction. So 1/4 becomes 4/1. Before I multiply, I'm going to look for numbers on the top and bottom that have common factors. This is known as canceling. I'm going to go ahead and highlight the 2 and 4 because I know that they have a common factor of 2. If I go ahead and divide them both by 2, my new numbers are 2 and 1. I don't see any other common factors here, so I'm going to go ahead and multiply. 1 times 2 is 2, and 1 times 1 is 1. And we know that 2/1 simplifies to 2. And once again, we can see that voila, we get the same final quotient of 2. Okay, let's go ahead and try another one. 1/2 divided by 1/3. Okay, let's start with our virtual manipulatives. I'm going to start by writing down my problem, which is 1/2 divided by 1/3, and then go ahead and model my 1/2. And then we're going to go ahead and just pull out a bunch of 1/3 pieces. Not sure how many we'll need. So I'm going to go ahead and pull that up. Okay, I've got 1 in there. Okay. So I can see now that I fit one whole 1/3 piece in there. But then beyond that, a second 1/3 piece, only part of it fits. Well, what I need to see here is that how much of that 1/3 piece fits. 1/2 of this 1/3 piece, I'm sure you can see from the line here that this is now split in half. Okay, so a total of 1 and 1/2 times is how many times the 1/3 piece fits. So my answer here is actually 1 and 1/2. Alright, go ahead and take a picture, and let's drop that into GoodNotes. Okay, now let's try this using an equation. So again, I'm going to write 1/2 divided by 1/3, and I'm going to rewrite this as a multiplication problem. 1/2 stays the same, division becomes multiplication, and we're going to find the reciprocal of that second fraction. So 1/3 becomes 3/1. I'm going to look for common factors on the top and bottom. I don't see any, so I'm going to go ahead and multiply. 1 times 3 is 3, and 2 times 1 is 2. So I get a quotient of 3/2, which hopefully you can see that the improper fraction 3/2 simplifies to the mixed number 1 and 1/2. So once again we see that we get the same final quotient no matter what method we use. Okay, let's try another one. Now we've got 1/4 divided by 3/8. Let's go ahead and pull up our virtual manipulatives. Alright, and let's go ahead and write down our problem. So we've got 1/2 divided by 3/8. Start by modeling that 1/4, and then we're going to see how many times our 3/8 will fit in there. Now the important thing here is to remember that we're not just doing 1/8 now, we're doing 3/8. So this counts as 1 time going in, not 3 times. Okay? Okay, so let's start by pulling these pieces up. Okay? Okay. And we can see here that 2 of the 8ths fit in very nicely to our 1/4. But then this other 1/8 piece here of the 3/8 doesn't fit in very well. Well, if we think of the 3/8 as a whole, that means that 2 out of the total 3 pieces will fit in there. Or in other words, 2/3 of the 3/8 will actually fit in 1/4. So our quotient here is 2/3. Go ahead and take a picture, and let's drop that into GoodNotes. Alright, now let's try the same thing using an equation. So again, I'm just going to start by writing down my original equation, which was 1/4 divided by 3/8, and I'm going to rewrite this as a multiplication problem. So we'll be writing 1/4 times, find that reciprocal, so we get 8/3. Before we multiply, look for numbers on the top and bottom with common factors. Do you see any? I see one, 8 and 4. Both of those numbers are divisible by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So I'm going to cross off my old numbers, and I've got my new numbers here, 2 and 1. I don't see anything else I can cancel, so I'm going to go ahead and multiply straight across. 1 times 2 is 2, and 1 times 3 is 3. So we get a quotient of 2/3, which, if you remember, is the same that we got with our other method, so we know we did it correctly. Okay, let's try another one. Now we've got 2/3 divided by 1/6. Again, let's try it with the virtual manipulatives first. I'm going to start just by writing down the problem. So 2/3 divided by 1/6, okay? And then I'm just going to go ahead and start by modeling my 2/3. Okay? And then remember, once you've got 2/3 modeled, we're looking to see how many times 1/6 will fit into that 2/3. So I'm just going to pull out a bunch of 1/6 pieces, not sure how many we'll need, and start dragging them underneath my 2/3. Got 2 in there. Okay, so we can see that we can comfortably fit a total of 4 1/6 pieces. So that means that 2/3 divided by 1/6 is 4. Go ahead and take a picture, and we'll drop that into GoodNotes. Okay, second method, let's go ahead and use our equation. So we've got 2/3 divided by 1/6. Again, we're going to rewrite this as a multiplication problem. So we've got 2/3 times reciprocal of 1/6 is 6/1. You got it. Look for things you can cancel. I spy a 3 and a 6 that have a common factor of 3. I'm going to divide them both by 3. 3 divided by 3 is 1. And 6 divided by 3 is 2. So we're going to multiply my new numbers together. 2 times 2 is 4. And 1 times 1 is 1. And we know that 4/1 simplifies to 4. So once again, we get a final answer of 4. Okay, let's try another one. Alright, now we've got 3/4 divided by 1/8. Let's go ahead and pull that up on here in virtual manipulatives. Okay. Oops, let me just double check something. Yep, okay. Just want to make sure I had the right problem, sorry. Okay, so I'm going to write down my 3/4 divided by 1/8. Alright, and first steps first, model my 3/4. Okay. So we've got our 3/4 modeled. And again, we need to figure out how many times the 1/8 will fit in a 3/4. So I'm going to pull off a bunch of 1/8, not sure how many we'll really need. And I'm just going to start placing them underneath my 3/4. Okay, and I can see that I can fit that 1/8 piece inside of 3/4 a total of 6 times. So we get a quotient of 6. Okay, go ahead and take a picture and drop that into GoodNotes. Alright, and then let's try that also using an equation. So again, I'm just going to start by writing down 3/4 divided by 1/8. Okay, I'm going to rewrite that as a multiplication problem. So we've got 3/4 times 8/1. Look for things you can cancel. I see I've got a 4 and an 8 here. I'm going to go ahead and divide them both by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Nothing else I can cancel, so I multiply straight across. 3 times 2 is 6. 1 times 1 is 1. And we know that 6/1 will simplify to 6. So once again, we get the same quotient both times. Alright, let's go ahead and try another one. 1/4 divided by 1/12. Alright. Write that down. 1/4 divided by 1/12. Oops. So I'm just going to start by modeling 1/4, which I've got here. And I need to figure out how many times 1/12 will fit into 1/4. So let's just go ahead and pull out a bunch of 1/12 pieces. And I'm going to start placing them underneath the 1/4. Alright, and I can see that the 1/12 pieces fit in a total of 3 times. So my quotient here is 3. Okay, go ahead and take a picture. And drop that into GoodNotes. Okay. And now I'm going to just double check that using the equation. So I'm going to do 1/4 divided by 1/12. Okay. And I'm going to rewrite that as a multiplication problem. So 1/4 times 12/1. Look for things in the top and bottom I can cancel. I spy a 4 and a 12 that are both divisible by 4. So if I go ahead and divide them both by 4, 4 divided by 4 is 1. Cross off your 4. 12 divided by 4 is 3. Cross off your 12. And then we multiply straight across. 1 times 3 is 3. And 1 times 1 is 1. And then we know that 3/1 will simplify to 3. And once again, we see we get the same quotient both times. Okay, so our next one is 1/2 divided by 2/8. So let's go ahead and pull it up in our virtual manipulatives. So I'm just going to start by writing my problem down. 1/2 divided by 2/8. And I'm just going to start by modeling my first fraction, which is 1/2. Okay? And remember, we want to figure out how many times 2/8 will fit into 1/2. So I'm going to pull out my 1/8 pieces, but remember that 2 of those are going to represent each group. Okay? So if I pull up 2 1/8 pieces, this represents one group of 2/8. Okay? So I'm just going to underline that so we remember that. Okay? Then I'm going to pull up another group here. Okay? And so we can see that a total of 2 groups of 2/8 will fit inside 1/2. So my quotient here is 2. Go ahead and take a picture and drop it into GoodNotes. And let's just go ahead and double check that using an equation. So we've got 1/2 divided by 2/8. So I'm going to rewrite that as 1/2 times 8/2 and look for things I can cancel. I see right here within the same fraction I can divide 8 and 2 by 2. So I'm going to go ahead and do that. 8 divided by 2 is 4. And 2 divided by 2 is 1. Okay, I also see I've got a second set of items I can cancel here with this 4 and 2. Once again, I can divide them both by 2. So I'm going to go ahead and do that. Okay. So now my new numbers here, I've got 1 times 2 and 1 times 1, which gives me 2/1, which simplifies to 2. So once again, we get the same final answer. All right. Okay, now that is going to conclude our lesson on dividing fractions by fractions. Make sure you do the note check before moving on.